welcome back. Today we're going to be taking a look at product to sum and sum to product formulas. Now these are kind of a little bit lengthy and a little bit long, as you kind of can tell from our product to sum formulas here. And there are patterns to them, but they do take a while and you do have to memorize these. Alright, so the first one we can take a look at, of course, are what we call the product to sum formulas. What these are going to allow us to do, if you notice, is allow us to multiply trig values of different angles together. And there's kind of a pattern, like for example here you got sine A, sine B, cosine A, cosine B. They're the same exact formula except for in the middle here. Sine is negative, cosine is positive. If you have sine A, cosine B, or cosine B, sine A, if you switch them again, same formula, but if sine goes first, it's positive, cosine first, negative. And these are very easy to use. Now, what we want to do here, for example, we want to rewrite sine of 5 theta, cosine of 3 theta. So I just recognize the pattern. This is sine cosine, so it's going to be our third one here. And my rule says to write this as 1/2 the sine of adding these together. Well, 5 plus 3 is 8, so we get 8 theta, plus the sine, and then we subtract them, we get, well, 5 minus 3, 2 theta. And there's our answer. Now, a lot of times what happens is students think, hey, look, I can distribute the 1/2, but this is not true. See, not equal. This does not become the sine of 4 theta plus the sine of theta. Don't do that. Every time you do that, remember, a kitten dies. Just leave it like this. And that's basically how we use our product to sum formulas. We'll see more examples in just a little bit. The next ones we take a look at are the sum to product rules. Now, if you're planning on taking calculus next year, these ones you need to know. Okay? These ones you need to know here. So, and again, they're just kind of going backwards with a little bit of property manipulation. So, again, there's a pattern. If you have sine A, sine B, and now we're going to be adding two different angles. So, sine A plus sine B, sine A minus sine B. Almost the same formula right here, if we take a look right there. If you have sine A plus sine B, you get 2 sine cosine. Sine A minus, we just switch the cosine and the sine. Remember, we're adding first, subtracting second. If we have cosine plus cosine or cosine minus cosine. Now, for cosine plus cosine, it's easy. It's just cosine cosine. That's going to be easy to remember. Cosine plus cosine, we get cosines. Cosine minus cosine, we get sines, but we make it -2 instead of positive right there. Okay, so be very careful. And again, it's plus plus, minus minus. So these are always easy. Remember, the first term's always we're adding, the second one we're subtracting. And we're going to use this the most often, especially in pre-cal and calculus, when we start manipulating what we call integrals. So we want to find the exact value of the sine of 2 different angles without a calculator. So my rule says here, it's sine with a plus, so be careful. So we take a look here, it's our first one, and my rule says to do 2 sine, adding them together, 195 plus 105, divide that by 2, and I get the cosine of the same thing, but this time subtracting them, 195 minus 105 divided by 2. Doing a little bit of math, this is 300 over 2, which is 150 degrees, and the cosine of 90 over 2 is 45 degrees. Now, if you're like me, I always have trouble with angles. I use radians. This is a 30-degree angle in the second quadrant, so this is sine of 5 pi over 6 times the cosine of pi over 4. And this becomes 2. The sine of 5 pi over 6, 1/2, and the cosine of pi over 4, root 2 over 2, cancel, we're left with the root 2 over 2. And there's our final answer. We also use this to solve equations. Like if I want to solve sine of 5x plus the sine of 3x, please do not write this as the sine of 8x. A kitten dies when you do that. We can't combine them because they're different. This is not sine times 5x, it's the sine of 5x. So we can't add them together, we can't combine them. But we can use our property. Because it's sine plus sine, there's my rule again. I'm going to use the same rule as before. My rule says right, it says 2 times the sine. Adding these together, I get 8x over 2, and I get the cosine, subtract them, 2x over 2 equal to 0. And I can solve. I get 2 sine of 4x cosine of x equal to 0. This is what we want. Okay? Now, to solve it, get rid of the 2 first by dividing it. Those cancel, and what we're left with is this. The sine of 4x times the cosine of x equals 0. And that's what we're going to solve. Using the zero product property, we set each one of these factors to 0. That's what that zero product property was for in Algebra 1. We get the sine of 4x equals 0, and down below there I'm going to write down the cosine of x equals 0. So let's do cosine first. We know what that's true. Where is cosine equal to 0? Easy. Pi over 2, 3 pi over 2. Now, for sine is a little bit harder because it's 4x. Where is sine equal to 0? That's 0, pi, 2 pi. But because of the 4, remember, we're going from 0 to 2 pi normally for our answer. That 4 means we have to go around the circle 4 times. 4 times we got to go around the circle. Now, why did I put the 4x out here? Because that's normally my x. X equals that, but it's 4x this time. Now, going to 2 pi gets me around the circle once. Go around again, 3 pi, 4 pi. That's twice around the circle. Keep going. 5 pi, 6 pi. That's 3 times. One more time, 7 pi, 8 pi. Now we've gone around the circle 4 times. Divide each one of those by 4. We get 0, pi over 4. 2 pi over 4 becomes pi over 2. 3 pi over 4. 4 pi over 4 becomes just pi. 5 pi over 4, tough one. 6 pi over 4 becomes 3 pi over 2. Here we get 7 pi over 4, and of course this just stays 2, becomes 2 pi. Now notice we have pi over 2, 3 pi over 2. These are repeats. You don't need to include them. So there is our answer right there. Very easy to do. All right, now stick around for part 2, okay? We're going to go just do a few more examples of these and let you guys do some practice at home, okay? And we're going to practice more of these in class tomorrow.